Welcome to this video where I will be going over a predicted paper-free calculator for the higher tier for the Edexcel exam. This paper has been put together by Third Space Learning, so do go and check them out on their website. Now, if you're an AQA student, you can still benefit from this video. You just got to remember that your paper will have a different format. You'll still be tested on the same topics, the same methods, but just will have a slightly different format in the way that the questions are presented to you. You may have things like multiple choice, for example, but there's plenty that you can benefit from. So get your pen, paper, everything that you need ready, and let's dive right into it. For question number 1, simplify p cubed times p to the power of 4. What do we do here? Well, we have the base p the same, so we can just add the powers. So it will be p 3 plus 4, and that gives us p to the power of 7. Part B, simplify 12q to the power of 7 divided by 3q squared. Now, when you're dividing, let's zoom in here a little bit. When you're dividing, you take away the powers. But before we do that, let's focus on the numbers. So 12 and 3, what can they both be divided by? They can both be divided by 3. So when you divide 12 by 3, you get 4. And when you do 3 divided by 3, you get 1. So you have 4q to the power of 7 divided by q squared. And now we can just take the powers away from the q. So it will become 4q, and then we do 7, take away 2, so that gives us 4q to the power of 5. Question number 2. A number n is rounded to one decimal place. The result is 8.7. Complete the error interval for n. So what do we do with these questions? We put our 8.7 in the middle, and then we write down our inequality signs. So on the right hand side, we write just a less than, and on the left hand side, we write a greater than and equal to. So what will be our upper bound? Our upper bound would be 8.75, and our lower bound would be 8.65. So there I have completed the error interval. Question number 3, here is some information about the number of siblings that 32 children have. Work out the mean number of siblings. When you're calculating the mean, you need to extend your table and draw a third column, which you will label fx. Now, how do you find the values that go into this column? You just multiply across. This is your x and this is your f. So you just multiply those across. So the first one is going to be 8 times by 0, which is 0. Next one is going to be 13 times by 1, which is 13. Then we're going to have 7 times by 2, which is 14. Then we're going to have 3 times by 3, which is 9. And then 1 times by 4, which is 4. If this was in groups, then you would need to find the midpoint. So you'll draw a separate column, call it x, and then find the midpoint, and then multiply that with the frequency. Okay, but this wasn't in groups, so it was just like that, so you can just multiply across. Next, what you want to do is you want to calculate the total of this. Okay, so you add these up. So if you do 0, 13, 14, 9, and 4, you get a total of 40. So to find the mean now, it would be the sum of the f of x, which is the total of the f of x, which is 40, divided by the total of the frequency. So you can either do the addition of that, or you have the frequency total up here, which is 32. So this is 32. So you're going to do 40 divided by 32, and that gives you 1.25. So that is your mean. Part B of this question says one child is picked at random. Stacy says the probability that the child has at least 2 siblings is 5/16. Is Stacy correct? Show how you decide. So if we just highlight here, has at least 2 siblings. So if we go back to the table and we look at the number of siblings, at least 2 siblings means 2 or more. Okay, so we can have 2, 3, or 4. So that means we want to add all these numbers up, all these frequencies. So it will be 7 plus 3 plus 1 out of the total number of people, the siblings. So that will be out of 32. So if you add that up, you get 11/32. So this is the probability of at least 2 siblings. Now, Stacy says that it should be 5/16. So clearly you can see that 11/32 is not equal to 5/16, and therefore Stacy is wrong, incorrect. Question number 4. Here is a regular hexagon. Work out the size of angle x. Give reasons for each stage of your working. So we want to find this angle right here. What does the word regular mean? regular means that all the sides and all the angles inside our hexagon are the same. That means this side here is the same as this side, this, and this. And also this angle here is the same as that, same as that, same as that. All of these are equal. Now, if we focus on where our x angle is, we have this triangle. So if we label like this to indicate that they are the same lengths, what kind of triangle do we have right there? We have an isosceles triangle. And what does that mean? If we have an isosceles triangle, that means the bottom two angles are the same and the two lengths on the side are the same. So if this is x, this is also going to be x. So that means right here, this is also called x. Now, if we were to find what this angle is using n minus 2 times by 180, which is the sum of the interior angles of a polygon, we can then do 180, take away the angle, and then divide it by 2 to find out what x is. So let's go ahead and do that now. So n minus 2 times by 180 will tell us the sum of the interior angles. So in our case, we've got a regular hexagon. A hexagon has 6 sides or 6 angles. So we'll do 6 minus 2 times by 180. And that gives us 720. So if we want to find out what one angle is, i.e. this one right there, or any of them, we just do 720, divide that by 6, and we get 120 degrees. So that means this angle here, let's zoom in here, is 120 degrees. Now, what did I say earlier? I said if we have this as 120 degrees, then we can now do 180, take away 120, divide that by 2, and that will give us our x angle. So that gives us 60 on the top, divide that by 2, that's 30 degrees. So x is 30 degrees. Now, the question did mention give reasons for your answer. So one of my reasons is to identify this was an isosceles triangle. And the second one I need to give as a reason is angles in a triangle add up to 180 degrees. Okay, so that's my second reason. Let's go on to part B. It says work out the size of angle Y. So if we look back at the diagram, angle Y is up here. Okay. Now, how many marks is this? 2 marks. Okay, because there are actually a couple of ways that you could do this. So we judge which method and how long they should take by looking at the number of marks that a question has. All right. So let's go for something quite simple. Here we have a line. We have a line right there. Now, because it's a regular hexagon, remember that, these two lines would be parallel, okay? This one will be going this way and this one will be going that way. Now, we have a line that cuts through like that, right? Which means that there's a relationship between the angle x here and the angle y there. So let me quickly show you this on a separate diagram. So if you have two parallel lines like this, and you have a line that comes through like that, then this angle here and this angle here are related. They are alternate angles. They are the same. So if you look back at our diagram, we have x here and y here, so they're going to be alternate. So earlier on in part A, we found out the value of x. X was equal to 30, and x will be equal to y because they are alternate angles. So therefore, y would be 30 degrees also. Question number 5. This is a big question. It's worth a total of 7 marks. So let's zoom in here and work on one part at a time. So if we do a quick reading, a company is designing some new packaging in the shape of a cuboid. The packaging must have a height of 16 centimeters, a length of 9 centimeters, and a width of X centimeters as shown below. The company wants the surface area to be less than 900 centimeters squared. Let's highlight that. Show that 50x plus 288 is less than 900. All right, so where do we begin? Well, clearly you could see that it's talking about the surface area, so that'd be a good place to start. So let's go ahead and find the surface area of our cuboid, okay, of all the faces. So what do we have? We have a face right here, and we have the same face on the other side. So let's call this number 1 and point to the back and call it number 1 as well, because it's the same. Then we have a face on the top, and of course we're going to have the same face on the bottom as well. So let's give that another number because it's a different, it's got different lengths. and of course number 2 will also be at the bottom. And then we have this face at the front here, and we have another one at the back right there. So we can call that number 3, and we've got number 3 at the back. So if we one by one work out each of the faces, so let's start with number 1. So we have 16 times by x, the area of one of these faces. Okay, so 16 times by x is 16x. Now we have how many of those? We have 2 of those because we've got one on the other side. So we're going to times that by 2, and that gives us 32x centimeter squared. So 32x centimeter squared is that and the one at the back. Let's do the same for number 2. So number 2 was up here. So what do we know? We know this length is going to be x. Okay, we need to know what this length is, which is down here, 9. So it's going to be x times 9. So 9 times x is 9x. And we've got 2 of those. So times it by 2. So that gives us 18x centimeter squared. So that's that. Now do number 3. So number 3 is this one at the front right there, right here. And we've got another one at the back. So it's going to be 9 times by this height here, which is 16. So 9 times 16. So 9 times 16, let's just write this out. It's a calculator paper, remember that. So you could just knock this into your calculator. Remember, you need to times it by 2 as well. So 9 times 16 times by 2 is equal to 288 centimeter squared. So now, if I was to add all of these up, that would give me the total surface area. So let's go ahead and do that. So total surface area would be equal to 32x plus 18x plus 288. If we do the 32x plus 18x, that would be 50x. So that would be 50x plus 288 centimeter squared. So this here is the total surface area. Now the company wants this to be less than 900 centimeters squared. So let's write that down. So we can write 50x plus 288 less than 900. And that is what it wanted me to show. So that's for 4 marks. For part B, it says solve 50x plus 288 less than 900. So what we just had. So to solve this, we need to imagine this is an equal sign and just deal with it like that. So we'll still write an inequality, but we'll treat it as though we are doing a linear equation. All right, so that's 50x. Take the 288 to the other side. So you do 900, take away 288, and then that gives us 612, so 50x, and then we divide by 50 both sides, so 612 divided by 50, and that gives us x is less than, put that in your calculator, you get 12.24 centimeters. So x, the range of values for x is less than 12.24 centimeters. Part C says that x must be an integer, which means a whole number. Okay, so a whole number. Write down the greatest possible value for x, and it has to be an integer, a whole number. So the greatest possible value for x, which is less than 12.24, the whole number nearest to that, the greatest whole number, is 12. So x will have to be equal to 12. That's the greatest possible value of x. Question number 6. X is equal to 4 times 10 to the power of 5. Y is equal to 6 times 10 to the power of 3. Work out x plus 2y, giving your answer in standard form. Now, bear this in mind, you have a calculator at your disposal, so you don't have to use the non-calculator techniques required for standard form. So, first of all, let's try and figure out what it's asking us to do. X is equal to all of that. Y is equal to this. Let's put that into some sort of expression. So 4 times 10 to the power of 5 is x, plus 2 lots of y, which is 6 times 10 to the power of 3. And we can just put this into our calculator, but before we do that, let's just do a little bit more simplifying. So 12 times 10 to the power of 3. Notice this is not in standard form. It needs to be 1.2. So this is my calculator. So I'm going to show you how to put this into your calculator. So you press 4, and then see that exponential button on the bottom. You can press that. On your calculator, it might come up with a different symbol. It might have 10 to the power of something and a times sign as well. On my one, it says E, but I will now press 5. That E represents times 10, okay, to the power. So I'll press 5. Then I'll press add. Now, it might be a good idea right now to use a bracket so you don't make any mistakes. So I'm going to do the 12 times 10 to the power of 3 like this. So 12 exponential and then the power only, okay, to 3, and I'm going to close that bracket. So I get 4, 1, 2, 0, 0, 0. Now, the question says that give your answer in standard form. This is clearly not in standard form because the number has to be between 1 and 2. So I'm going to have 4.12 times 10 to the power of something. Now, if you're making a big number smaller, like 4.12, you've made the 4 go to just in front of the decimal place, which is right here. So how many steps was that? 1, 2, 3, 4, 5. You've taken 5 steps. So your power would be to the power of 5. So your answer is 4.12 times 10 to the power of 5 in standard form. Question number 7, write 48 meters squared in centimeters squared. Some of you may be tempted to just, multiply this by 100 or something. Don't do that because you are working in area, okay, not lengths. So if we write down some things, so 1 meter we know has 100 centimeters. This is the length, okay? But when you do 1 meter squared, it's not equal to 100 centimeters squared, okay? 1 meter, if we do this, 1 meter, if we work out the area here, 1 meter is equal to 100, isn't it, centimeters? So therefore, when you calculate the area, you do 100 times 100, which is 10,000 centimeter squared. So that means 1 meter squared is equal to 10,000 centimeter squared. That's what you need to do. So if you want to go from meters to centimeter when it comes to area, then you're multiplying by 10,000. So we want to go from 48 meters squared to centimeters squared. So we're going to do 48 meters squared times by 10,000. And that gives us 480,000 centimeter squared. And that's your answer. Question 8. Here is a plan of Harry's garden. Harry wants to create a wildflower meadow. To do this, Harry is going to mix a wildflower seed mix with a grass seed mix in the ratio 2:5. Harry will then spread the seed mix on his garden. 1 kilogram of his seed mix will cover 20 meters squared. Grass seed comes in 5 kilogram bags, which cost £32 each. Wildflower seed comes in 1 kilogram bags, which costs £21 each. Work out the total cost of the seed for Harry's garden. So we've got this problem solving question, very, very wordy. What kind of topics we are going to be using? We're going to need to know how to find the area of a rectangle. We are dealing with ratios, and we are dealing with, cost of things, okay? Proportion. So where do we begin? A good place to start would be to calculate the area of Harry's garden. So let's start there. So Harry's garden, the area of garden would be to simply do 24 times by 10.5. And if we work that out, that gives us 252 meter squared. So that's the size of Harry's garden. Now that we know the area of the garden is 252 meters squared, let's find out how much seed mix will be used in that. So if you read down here, it says 1 kilogram of his seed mix will cover 20 meters squared. So for the seed mix, we can do 252 divided by 20. And that gives us 12.6 kilograms. So this is the amount of mix that is needed to cover the entire garden. Now, it says the wildflower seed mix with the grass seed mix is in the ratio 2:5. So we can say here, let's use W for wildflower and G for the grass. It will be 2:5. So we have 7 parts here. So we are going to need to divide 12.6 into 7 parts, because remember, this is the seed mix, and that is the seed mix right there. So we're going to do 12.6 divided by 7, and that gives us 1.8. So it's 1.8 kilograms per part. So now that we know that it's 1.8 kilograms per part, for the wildflower, what we can do is 2 times by 1.8, and that gives us 3.2 kilograms. But remember, we can't just buy 3.2 kilograms because wildflower seeds come in 1 kilogram bags. So we're going to need 4 kilograms. Okay, we can't buy 3 kilograms because we'll be short. And we'll do the same thing for the grass seed. So grass seed, we do 5 times by 1.8, and that gives us 9 kilograms. Once again, if we read the question, it says grass seed comes in 5 kilogram bags. So again, we're going to need to buy 2 5 kilogram bags, so we need 10 kilograms, okay? So 10 kilograms. Now, let's work out the costs, because that's what the question is asking us to do, the total costs. So for the wildflower, it costs £21 each, 1 kilogram bags. So how many of that do we need? We need 4 of those. So it'd be 4 times by £21, and that gives us £84. And if we do the same thing for the grass seeds, that costs £32 each. We need 2 of those bags because they come in 5 kilogram bags. We need 10 kilograms. So we are going to do 2 times by 32. And that gives us £64. So the total costs will be to add up 84 and 64. And that gives us £148. So the total cost to seed Harry's garden is £148. Question 9. The probability tree diagram shows the probability that Richard's bus will be late on the weekend. Complete the tree diagram and calculate the probability that Richard's bus will be on time on at least one day. And this is for 4 marks. So let's go in. Now with probability branches, they all add up to 1. Okay, so that's got to add up to 1. Here, that's got to add up to 1. That's got to add up to 1. Okay, so to work out not late, we are going to do 1 take away 0.32, and that will give us 0.68 right there. To work out not late here, we're going to do 1 take away 0.4, and that gives us 0.6. And the same for the bottom one as well, 0.6. So we've done completing the tree diagram. For part B, to calculate the probability that Richard's bus will be on time on at least one day, we can either do all the different combinations where it's on time on at least one day, or do the following. We can do probability on time at least one day equal to 1 take away the probability that it's late on both days. You see, when something is late on both days, that means you've eliminated the probability where it's late on Saturday and on Sunday. That means it's either on time on both days or on time and then late. Okay, and it's a quicker way to do this. So if we want to work out the probability of late on both days, that means we just use that and take that away from 1. So let's go ahead and do that. So probability of late both days, we are going to do 0.32 times by 0.4, and that gives us 0.128. So just a quick reminder, this is what I just calculated. Okay, the probability of being late on Saturday and the probability of being late on Sunday. And is time sign we have to use. All right, so now we're going to put this in here, and we're going to do 1 minus 0.128, and that gives us 0.872. So the probability that Richard's bus will be on time on at least one day is 0.872. Question 10, for 3 marks, we have a triple bracket expansion. Now with these questions, they're great fun to do. All you've got to decide is which bracket to ignore first, either the first one or the last one. Okay, you can decide. All right, so let's just ignore this one for now. So 2x plus 1. And then what we're going to do is expand this bracket and put the result in here, write it out, and then we're going to expand that out with the rest of that. Okay, so let's do 3x times x. That is 3x squared. 3x times 2 is plus 6x. And then we're going to do 5 times minus x, which is minus 5x. And then we're going to do minus 5 times 2, which is minus 10. And then we're going to collect the like terms. So that's 3x squared. 6x minus 5x is just plus x minus 10. And then we can write this one. Now we're going to expand those two brackets. So 2x times that, 2x times that, 2x times that, and then we'll do the same thing for the 1. Okay, so let's just do the 2x first. So 2x times 3x squared is 6x cubed. 2x times x is plus 2x squared. 2x times minus 10 is minus 20x. And now we're going to do the 1. So 1 times 3 x squared, 1 times x, 1 times minus 10. So that's going to be, first one, 1 times 3 is plus 3x squared, then 1 times x is plus x, and then 1 times minus 10 is minus 10. Now we just need to collect all our like terms. So 6x squared has 6x cubed rather has no like terms, so 6x cubed can stay. 2x squared and plus 3x squared, we can collect those, so that gives us 5x squared. And then we have minus 20x plus x, so that's going to give us minus 19x, and then minus 10, which has no like terms. So that's our final answer. Question 11, write 540 as a product of its prime factors. So we can just do 540. Now, what do we divide by? We divide by the prime numbers. And what are the prime numbers? Prime numbers are numbers that only have 2 factors. So let's write this down. The first one is 2, then 3, 5, 7, 11, so on and so forth. So these are the numbers that we want to divide by. So what can we divide by? We can divide 540 by 2, but we can also divide by higher prime numbers. We have a calculator, so we can be a bit more adventurous there. So if we divide by 5, 5 is a prime number, so we circle it. So 5 times 108 gives us 540, and then we can break down 108 as well. So 108, we get 3 times 36, circle the 3, the 36, we can do 3 and 12, circle the 3, the 12, we can do 3 and 4, circle the 3, and then the 4, we can do 2 and 2, and we circle that as well. So as a product of its prime factors, we're going to have 2, how many times? 1, 2 squared. We're going to have 3, 1, 2, 3, 3 cubed, and times by 5. So that's my answer. For part B, it says, hence, write down the smallest number that 540 could be multiplied by to give a square number. Very unusual question. We don't normally get asked this question. Now, if you look at this, you'll notice that when we got to this stage right there, we had our first square number when we were breaking it up. So 36 is a square number. So that means these two numbers, we can multiply them first. So we can do 5 times by 3 to give us 15. And 540 times by 15 will give us a square number. So if we put this into our calculators, we get the number 8100. Okay, now this is a square number because if you do the square root of 8100, you get 90. Okay, so the smallest number that 540 could be multiplied by to give a square number is 15. Okay, the number right there. Question 12. An object exerts a force of 80 newtons on an area of 16 centimeters squared. Brian increases the area of the base of the object, which decreases the pressure caused by the force by 20%. By what percentage does Brian increase the area? All right, so we need a formula here. The formulas are usually given to you. So this formula will be in the corner of your exam. So it's not on this one, but I'll just write it in. Okay, this is the formula for pressure. So if we work out the current pressure that we have right now, we've got a force of 80 newtons on an area of 16. So currently we have the pressure as 80 divided by 16, and that gives us 5 newtons centimeter squared. So this is the current pressure. Okay. Now, if Brian increases the area of the base of the object, and that goes on to decrease the pressure caused by the force by 20%. So a decrease of 20%. By what percentage does Brian increase this area? All right. Remember, it's division. That's why as you're increasing one thing, you're decreasing overall, because the number at the bottom of our fraction, when it gets bigger, it makes the overall number smaller, the pressure in this case. All right. So let's look at a decrease of 20%. A decrease of 20% is a multiplier of 0.8. So we are going to decrease the pressure by 20%. Okay, so the current pressure is 5. So we're going to do 5 times 0.8, and that gives us 4. So 4 Newton centimeter squared is showing a pressure that has decreased by 20%. Okay, so now the question is, what area size would cause the 5 Newton to come down to 4 Newton? So if we now use the same formula again, we can now do this. P is equal to F over A. The pressure is equal to force divided by the area. If we want the force, if we know that the force has got to be 4, we can write a 4 here. So we make P equal to 4. And then the force stays the same. It's still 80 newtons. The area is the only thing that we need to work out. Okay, so if we work this out, so if we take the A over here and the 4 down here, we get A area is equal to 80 divided by 4. And that gives us 20 centimeters squared. Okay, so the area will need to increase to 20 centimeters squared from the 16 to decrease the pressure by 20%, decrease it from 5 to 4 newtons. But the question says, by what percentage does Brian increase the area? So to do that, let's just box this around here. So we are working at the percentage change, okay, the percentage change. And to work out the percentage change, we do the difference divided by the original amount times by 100%. So what's the difference? Well, for the area, we're working it out, right? So to work out the difference, we do 20 minus our original, which was 16. So the difference is 4, okay, 4 centimeter squared. So we do 4 divided by the original area, which was 16, and then we times it by 100%. And that gives us 25%. So we need to increase the area by 25% to decrease the pressure by 20%. Hope that makes sense. Go back over it again, rewind, and just follow through. And if you have any questions on this, just write in the comments and I'll try to answer them. So question 13, a Venn diagram question. We'll work on each bit at a time because there are a few different parts, a total of 4 marks. So we are told the Venn diagram shows the number of year 11s who study French, German, and Spanish. One student is chosen at random. Write down the probability of F, which is that they study French. So French circle is all of this. So if we want to work out all the French students, we add up all of those values right there. So we do 53 plus 11 plus 3 plus 6, and it's all over the total number of students. And to work out the total number of students is simply to add up every single value, including the one outside. All right, so we are going to do that on our calculator. So you just put this into your calculator, you get 150. So on the top is 73 over 150. So that's the probability of the students that study French. Now, what does this mean? Probability of G union S. Union, that means or. So what's the probability that they study German, that's the G, and Spanish? Okay, so it's an or question. So if we look at the circles for German and Spanish, we're only adding up all of those values right there. Okay, so we're not including the French's 53 and the outside number of 12. Okay, so we're going to add those up only. So we're going to do, let me zoom out here, 39 plus 11 plus 3 plus 8 plus 6 plus 18. And that's going to be over the total again of 150 students. So if we work at the top, we get 85 over 150. So the probability that they study German or Spanish is 85 over 150. Now for part C, we have a very weird looking one. So pay careful attention to this one. This says a probability that they study French. This means and, okay, and these marks here means not German, not Spanish. So we're looking for the probability that they study French and don't study German and don't study Spanish. All right, so if we draw a smaller version of our Venn diagram to illustrate this, we have 3 circles. So we have 3 circles. We have French, German, and Spanish. So we are looking for the probability that they study French. So they study French here, they study French there, they study French there, they study French there. Okay, that's all of French. But if we don't want German and we don't want Spanish, and so they study French and not German and not Spanish, that means we can't really have those, okay, because they fall into the German circle and the Spanish circle, right? So we can't have that. So we're going to have to get rid of those, not like that. So we're going to have to get rid of that, that, and that. Okay, so we just want the number that is in here. If you go back up here, what's the number in here? It's just 53. Okay, so it's going to be 53 out of 150. So 53 out of 150. Part D, one of the students is chosen. The student studies German. Elliot says that the probability that the student also studies Spanish is 11 over 150. Elliot is not correct. Explain why. When you come across these types of questions, the best way is to actually work out the correct thing, and then you'll see that, why it's not right or why it is right if it's one of those questions where it is right. Now, this is actually one of those given questions, all right? So it says one of the students is chosen. The student studies German. This is your given part. You're given this part information, right? This is a given. So it's out of the number of students that study German. Now, the probability that the student also studies Spanish is needed to be found, all right? So how do we represent this? We write it like this. We say the probability that the student studies Spanish, S, given that they study German. Okay, this is it. So you might have seen this in your textbooks. Okay, this is actually also used at GCSE Further Mathematics and beyond. Right, so this means the probability of S and G, that's what you're looking for, divided by the probability of G. Okay, so this is standard practice. So if this is A, this is B, this would be A and B over probability of B, like that. Okay, so let's look for this. We're going to look for S and G. Let's see what that is. S and G. S and G is Spanish and German, which is those two, 3 plus 8. So it's 11. Okay, so S and G is 11. So S and G is 11. And now if we work at the number of German students, the probability of German students, that is going to be the entire circle right here. So it's going to be 11, 39, 8, and 3. So we're going to add those together. So 11 plus 39 plus 3 plus 8. And that gives us 61. So the probability that they study Spanish, given that they study German, is 11 out of 61. Now, we have to explain why Elliot's not correct. Well, 11 over 61 is not 11 over 150. So that's why. And what's Elliot probably done is he worked out of 150. Okay, he didn't understand that this is only out of the German student. So this should be 61. And this is for 1 mark. And this is enough explanation. Question 14. At the start of year T, the mass of a radioactive substance is MT. At the start of the following year, the mass of the radioactive substance is MT plus 1, where MT plus 1 is equal to 0.8 MT. At the start of 2021, the mass of a radioactive substance is 4,500 grams. Find the mass of the substance at the start of 2022. Right, so that's 1 year later. So to work this out, the mass in 2022, we're going to do 0.8. And what does this mean? Let's just zoom in here. So if you have T plus 1 and then you have T, that means MT is the year before that. Okay, so we're going to have M of 2021 because we are working out 2022. And we are given the start of 2021. We are told that is equal to 4,500. So 4,500 is going to go right in there. So it's going to be 0.8 times by 4,500. And that gives us 3,600 grams. So the mass in 2022 is 3,600 grams. Part B, the half-life of a radioactive substance is the amount of time taken for the amount of the radioactive substance to halve. Okay, to halve. Let's just highlight that. So it has to halve from 4,500 because that's a start. Okay, so half of that, so 4,500 divided by 2 is 2,000. Nigel says that the half-life of this substance is approximately 3 years, so it takes 3 years. Is he correct? Explain how you decide. Well, we've just done 2022, which gave us this. So it's starting to decrease. Let's do 2023 and see what happens. So in 2023, we're going to do 0.8 times by 2022, which is 3,600, and that gives us 2,880. So it's not quite there yet, because remember, for it to half, it has to be 2,250. So let's do 2024. So that's going to be 0.8 times by 2023 now, so 2880, and that gives us at 2,304 grams. So we're almost there, but it's not quite there yet, but it's very, very close. Let's see what happens in 2025. So M 2025. So now we are in the fourth year, because remember, this is year 1, 2, 3, and now fourth year. Okay, that's going to be 0.8 times by 2024, which is 2,304 grams, and that gives us 1,843.2 grams. So you can see that it's more than half now, but 2024 is much closer, because 2,304 is closer to the half point. Okay, whereas this one is very far from the half point. And also it says approximately 3 years. So the question says, is Nigel correct? Well, if you look at the third year in 2024, it was very close to halving, and it's an approximation. Yes, it's just a little bit more than 3 years. So that would be yes, Nigel is correct. So yes, Nigel is correct, because in the year 2024, which is the third year, it starts going next to the halfway point. Question 15. Here is a speed time graph for a train. Let's zoom in here a little bit. Describe what is happening between 10 and 13 seconds. So if we zoom in a little bit more, I don't know if you can see this very well. Hopefully you can. Go and find where 13 seconds is. So we need to work this out by counting the squares. So it seems 10 to 15, it will be 1, 2, 3, 4, 5. Yeah, so that would be 13 right there. That's 13. So as you can see, between 10 and 13, right there, we have a flat line. And on a speed and time graph, if you have a flat line, that means the speed is staying at constant, 12 meters per second. So what we can say here is that we have a constant speed. There is no acceleration. Okay, and that should give you your 1 mark. Part B says work out the distance traveled by the train in the first 13 seconds of the journey. So distance is to work out the area on a speed time graph. So the first 13 seconds, so if we now mark here with a ruler right there, we want to work out the area of all of this, which is a trapezium. So if we draw our trapezium right here, so to work out the area of a trapezium, we need the side up here and the length right there, and of course the height there. Right, so this would be the same as that, which is 13. From here to here would be this, which is 3, because it's going from 10 to 13, so that's 3. And the height would be 12. And to work out the area of a trapezium, we do A plus B divided by 2 times by the height. And A is 3 plus 13 divided by 2 times by the height, which is 12. We get 3 plus 13 is 16, divided by 2 times by 12. So 16 over 2 is 8. So it's 8 times 12, and 8 times 12 is 96. So it's 96 meters. So the distance is 96 meters. For part C, it says work out an estimate for the acceleration of the train at t equals 20. To do the acceleration at t equals 20, we draw a tangent at 20 on our graph. So let's go ahead and find where 20 is. So 20 is here. You go up, it's right there, that point right there. Okay, so we need to draw a tangent to that point right there. So let's mark that point. So to draw a tangent line, we get a ruler and we draw a tangent. So we need to only touch at one particular point. Okay, so I'm just going to quickly play around with this. So I'm touching at only that one point. Okay, so there will be some sort of range for your final answer, so don't worry too much if your line doesn't have the same gradient as mine. Okay, so what I want to do now is just extend this line out as far as I can. Right there, that should be okay. Let me see if I can just make it a little bit more there. That should be good. All right, so how do I work out the gradient of my tangent? I could draw a right angle triangle like this, and I'm looking for particular corners, like here. Okay, that's a corner right there. It makes my life a lot easier. Can't do much about this one, so wherever that hits here. So to find the gradient, I do m is equal to the difference of the y divided by the difference in the x. So the y difference is whatever this is. So I'm to figure out what that value right there is. So if it's 12 to 14, the halfway point here would be 13. So to go right there, so that would be 1, 2, 3, 4, 5. So each of these would be 0.2. So that would be 0.2, 12.2 rather, 12.4, 12.6. So that's 12.6 right there. And from 12.6, it goes all the way up here. Let's just say that, and that would be 20. Okay, so 20 take away 12.6, so 20 take away 12.6, that gives us 7.4. So this height here for the y is 7.4, the difference in the y. And we'll do the same thing for the x right there, okay? And that's much easier to do because that will go from 0 here to 25. So that's just 25. And then we do 7.4 divided by 25. And that gives us 0.296. So the acceleration is 0.296 meters per second squared. You could write it like that, or you could write meters per second squared like that as well. Now, of course, there will be a small range. So depending on how you drew your tangent, you may have a slightly different answer. But as long as it's close to 0.2, then 0.2 something, then you're good. Question 16. M is inversely proportional to the cube root of n. M equals 46 when n is equal to 125. Find the value of m when n is equal to 8. So we are looking at inverse proportion. So we can write this as m is inversely proportional to 1 over the cube root of n. So we can replace the sign here with equals k. So that would be m is equal to k over cube root of n. Now we're going to use these two values to substitute and find our value for k. So that would be 46 for m is equal to k over the cube root of 125, which is the value of n. And if we now do 46 times by the cube root of 125, you could also find the value right there if you want and then multiply across, but it's the same thing here. That equals to k, and then if you put that into your calculator, you get 230. So k is 230. Now that you've found k as 230, you can go and replace it in here for that k. So your final equation that you're going to be using is 230 over the cube root of n. Now you can answer the question here. Find the value of m when n is equal to 8. So we're going to sub in 8 as our n value. So m is equal to 230 over the cube root of 8. And of course, the cube root of 8 is 2. So 230 divided by 2, and that gives you m is equal to 115. So that's your answer. Question 17 for 3 marks. O is the center of the circle. The line E to F is a tangent to the circle at the point B. The lines EF and GH are parallel. Angle ADC is equal to 42 degrees. Work out the size of angle CBF. Right, so with these questions, what I'd like to do is start off with what we're looking for. So we're looking for the angle CBF. So CBF, we are looking to find this angle right there. So let's mark that. That's the angle we are looking for. Now, where do we start after that? We've been given this angle here, so that would be a good place to start. We can see that there is an arc here, and these two lines come off that arc. So that 42 would be the same as this angle right there, because that's also coming from that same arc right here, like that, okay? So that is 42. So we can say that this here is 42, and we have to give reasons. It doesn't actually say in the question, but you have to give reasons. So you can say that CBA, this angle, is the same as CDA. So CBA is equal to CDA because angles in the same segment. Next, if you look at this is a tangent, okay? And we have a rule for that. See this triangle right there? We have the alternate segment theorem. So this angle here is going to be the same as this angle right there. Okay, they're going to be equal to each other. So what you can say is angle CAB is equal to the angle FBC. So the angle CAB is equal to the angle FBC or CBF, whichever way you want to write that, okay? And they are equal by the alternate segment theorem. So we can represent this also with a pink. Let's call it X, and we can call that X as well. Now, you can see this triangle forming, okay, well, it's already there. What if we knew how to find this angle right there? Is there any way that we can find that angle? Well, we can use the same rule and say on the other side, this angle here is also alternate with this one by the same theorem, okay? So we can say also ACB is the same as ABE right there, okay? So we can say that ACB is equal to ABE by the same theorem, okay? This one as well. So we can also mark that with an X. Now, look at this. If this is X and this is X, these two angles are the same, making this into an isosceles triangle. So that would also mean that these two lengths are the same. If we know that this is 42, we can do angles in a triangle is equal to 180 degrees, and it's an isosceles triangle, which we've proved. So therefore, we can do 180, take away 42, and then divide that by 2 to get one of our x's, okay? And remember, once we find this x, it's the same as that x, okay? So what's 180? Take away 42 divided by 2, that gives us 69 degrees. So x is equal to 69 degrees, and therefore the angle CBF is also equal to 69 degrees. So that's your final answer. Question number 18. Here is a graph of a circle. The circumference of the circle is 20 pi. Work out the equation of a circle. These are a total of 6 marks, so quite a big question. Let's work on the first part for now to find the equation of the circle. Where do we start? Well, this is important. The circumference of the circle is 20 pi. So let's write down a formula for the circumference of a circle. We know that this is pi d, or 2 pi r. So if we know that the circumference is 20 pi, we can just replace c with 20 pi and then write the rest of it, okay? Now we can cancel out the pi's, and we are now told that d is equal to 20, all right? So the radius of our circle will be half of the diameter, so the radius is going to be 10, all right? Now, what do we know about the equation of a circle? It's in the form x minus a squared plus y minus b squared equals r squared. The origin is the a and the b, okay, the center of the circle. So the center of the circle is our a and b. So our center is right here at the origin, 0, 0. So therefore, we're going to do x minus 0 squared plus y minus 0 squared equals r squared. R is the radius, so it's going to be 10 squared, okay, which is 100. So x minus 0 is just x squared, plus y minus 0 is y squared, and 10 squared is 100. So that is the equation of our circle. For part B, it says decide whether the point 7, 8 lies inside or outside the circle. You must show how you decide. Usually questions ask you whether a point lies on the circle itself. So anyway, so does 7 lie on the circle? And to do that, we sub in the value of x and the value of y, 7 and 8, into our equation. And if it gives us 100, then we know that it lies on the circle. But we're going to have to do something different here, okay? So let me just quickly take you back to the radius. So we worked out the radius was 10 earlier on, right there. So that means from the center to the side is 10 in any direction, okay? It's 10. So therefore, if what we find is greater than 10, it goes outside the circle. If what we find is, for the radius, is less than 10, then it's inside the circle, okay? So let's find out where 7 and 8 lies by subbing in x equals 7 and y equals 8. So x is equal to 7, y is going to be equal to 8. And let's find out what happens if we substitute this in, what value of r we get by using this formula right there, okay? So therefore that's going to be 7 squared plus 8 squared. We get 49 plus 64, and 49 plus 64 is 113. So remember, it's in the form r squared because that's the equation of a circle. So in order to find our r, we are going to do the square root of 113. And the square root of 113 is 10.63. So that means if we go back here, our r is greater than our radius, which is 10. 10.63 goes outside of our circle because it's just greater than the radius, all right? So we would say it's outside the circle because the radius is larger than 10. It's 10.63. Question 19. ABCD is a parallelogram. A to D is A and A to B is B. E is the point such that DE, EC is in the ratio 2:1. BCF is a straight line such that BF is equal to 3/2 BC. Work out the vector BD in terms of A and B. Okay, so if we look at this question and start writing down things that we were given in the question, first of all, let's start with E. Looking at E, this right there. We know that D to E and E to C is in the ratio 2:1. So all of this is the same as that because it's a parallelogram, okay? They're the same lengths, all right? So that means that this, just from here to here, in this direction, is going to be 2 out of the total of this, 3 parts. So it's going to be, E to F is going to be 2 out of 3 lots of B, because all of that is B, okay? Same as that, okay? And this is going to be a third of B. So 1/3 B in this direction. Next, BCF is a straight line. So BCF is a straight line such that from B to F, that's equal to 1.5. 3/2 is the same as 1.5, B to C. What is B to C? B to C just here is A. So therefore what we can say here is B to F is equal to 1.5 BC, which is A. So 1.5 A. Okay, so that's that done. Now let's focus on this B to D. Now, B to D, how do we get there? B to D, right there. We can't obviously go down diagonally like that. We have to go backwards here and then there. So it's going to be B to A plus A to D. And B to A is going back against the B, so it's going to be minus B. And then A to D is a positive, so it's positive A plus A. And we can rewrite this as A minus B. So B to D is A minus B. Part B of this question says prove that AEF is a straight line. Okay, so AEF, how do I prove that this is a straight line? What I can do here, I'm just going to zoom out and I'm going to need a lot of room for this. I need to prove that A to F is equal to A to E plus E to F. So you see, they're going to have the same points, so they're going to lie on the same straight line. Okay, I need a common point. So I'm going to prove that AE plus EF is equal to all of AF. But obviously, I'm going to find this separately, I'm going to find EF separately, add them together, and then that will give me a version of A to F. But I'm going to need to find another alternative version of how to get from A to F without going through this way. So I'm going to go through this way and that way perhaps, okay? So let's go ahead and do that. So first of all, let's focus on A to E separately. Let's just make this small. So A to E separately. Okay, let's find that. So A to E. So A to E, if we look at our diagram, is going from there to there. But I'm going to go this way and then that way, right there. So I'm going to do A plus 2 over 3B. So A to E is A plus 2 over 3B. Okay, and I'm going to do the same thing for E to F. So E to F. How do I do that? I can go up and then across. Okay, now one thing I should add here, I forgot to do it earlier, using this information, I need to find that. Okay, so if I know that from B to F is 1.5a, what would just this be? So if I know, look, all of this is 1.5a. So all of that is 1.5a. Then just this alone, because I've got 1a here already, this is going to be 0.5a to make up the 1.5a. All right, so 0.5a right there. So if I'm going back to now E to F, so E to F is going to be half of, oh, sorry, not half, a third B plus 0.5a. Okay, so it's going to be a third B plus 0.5a. In fact, I should be using this, either fractions or decimals, not mixing it. So let's use a half as 0.5. So a third B plus a half a. Now, why did I do this? Remember, I'm going to be adding these together. So I'm going to be adding that and that to give me AF. So we can say, therefore, AF would be equal to A plus 2 over 3B plus a third B plus a half A. And then we're going to collect all the like terms. So we have an A here, we have a half A here. That gives us 1.5A, which is 3 over 2A. And then we have 2 over 3B plus a third B. So that's going to give us a whole B, so plus B. And this is A to F. So I found one version adding up AE and EF for AF. Now I'm going to find an alternative way to get from A to F. Not this way though, okay? Because that's what I've just done. I said I'm going to go this way plus that way, okay? So I'm going to do B plus 1.5A, okay? 3 over 2A, okay? Remember 1.5 is 3 over 2. So an alternative AF is going to be B plus 3 over 2A. So just once again, B plus 3 over 2a, which is 1.5a. Okay, that's that. Now, if you look at this AF and this AF, you can see that they are the same. It's 3 over 2a plus b, 3 over 2a plus b. Obviously, they're written in a different order. So that's one way that we've proved it. Another way that we can also prove it, so it's an alternative way, is if you look at these two separately, we can try to factorize them. Okay, we can take out a common value. So here, the common value, we can take out a 2, for example. So we can take out 2. Therefore, the a would become a half a plus a third b. Okay, and then here, won't need to factorize anything out, but what we can do is just rewrite this as a half a first and then a third b. Now, what do you notice? Can you see that this is exactly the same, right? It's just A to E is twice as big. So that means they are going in the same direction. So they have the same direction but a different magnitude, but they have a common point, which is E. Okay, so that's another way that you can prove this. So AEF is a straight line. Question number 20. Here is a graph of y is equal to sine x. On the grid, sketch the graph of y is equal to sine x minus 1. What does a minus 1 do outside like that? It drops it down by 1. So all our points, okay, we can drop it down here. Okay, this will come down, this will come down right there. Okay, so we need to sketch this. So all the main points like this, okay, will go down here. Okay, this will go down here. Okay, this will go down here. This will go down here. Okay, 360 here. So we can just sketch that now. So we can do that, there, like that. Okay, That's that done. Part B, here is a graph of y is equal to cos x. A transformation is applied to y equals cos x. The new coordinates of the point A after the transformation is 181. So point A after the transformation is at 181. Currently it's at 180 minus 1. So to be at 181, it means it's gone up there. How could this have been? So you write down two possible equations for the new graph. So two different ways. The first one is, it could have just gone up as a shift. So, this could have been something like this. Okay, so it could go up by from here to here. So it's going to have to go from -1 to +1. So that's a jump of 2. So it could have been, the first one could be a translation up by 2, and therefore it would be f of x plus 2, and our f of x is cos x plus 2. So that's one. The other one that you could do is a reflection, okay, a reflection in the line right here, okay, which is y is equal to 0, okay, the line y is equal to 0. And reflection would mean that this has happened to it, okay. So the other way is a reflection in line y is equal to 0. A reflection means a minus outside our f of x, okay? So therefore that would be a minus cos x, like that, okay? That's our other way. So it's this one or that one. Question 21, the last question. Here is a diagram of a roof. The roof is made from two isosceles trapeziums and two isosceles triangles. So we've got this, and here, this is that drawn for us. And then we've got the trapezium on the sides, right there, and the other one at the back. The perpendicular height of the triangle ABC is 10% longer than the perpendicular height, or x, of the trapezium. So x here is the perpendicular height of our trapezium. If we do the same thing for our triangle, let's just break it down. So this is our h, let's call it h. We are told that h is equal to, so it's the perpendicular height of the triangle is 10% longer than. So if it's 10% longer than, the multiplier is going to be an increase, so it's going to be 1.1. So 1.1 of what is longer than the perpendicular height x of the trapezium? So 1.1x. So h would be equal to 1.1x. Okay, that's very, very important. That's an expression for our height of our triangle. Okay. Show that the length CF is given by the following. Okay, so CF, let's see what that is. That's this. So find an expression for that really and show that it's equal to this. That's what we want to do. Where do we begin? So first of all, we know that this triangle here is an isosceles triangle because these two lengths are going to be the same. So let's mark that in here. We have the length here as 4. So if we do decide we want to break this up into a right angle triangle, then this is obviously going to be 2. And we've got an expression for our height. For the trapezium, we have this as 10. We don't know this. This is eventually going to be that though. We do know that the two sides, CA and FD, are obviously going to be the same as that, because FD here and CA here of the trapezium are the same as the sides here of our triangle. So that's that. So let's start off by looking for, let's just break this down right there. Okay, so let's draw that. So that's C, that's A. We know this is going to be 2, as I mentioned, and this is H. So if we find an expression for that, because that's the sides, one of these sides, the same thing, right? This side links to that, okay? And obviously that. So we need to find a link like that, okay? That's how we're going to merge them together. So we can use Pythagoras' theorem to find this. What we can call this is, for now, is Y, because we are looking for that. So for Pythagoras' theorem, this is going to be C. We can call this A and B. So A squared plus B squared is equal to C squared. Our A is 2 squared. Our B is H squared, is equal to our C, which is Y squared. So that's going to be 4 plus H squared is equal to Y squared. And if we just want y, so y is equal to, we're going to square root the 4 plus h squared. So 4 plus h squared. Now earlier on, we had what h is. H is 1.1x. So we can replace this with 1.1x. So therefore, y is equal to the square root of 4 plus 1.1x squared. And we can also work this out. So this is going to be 4 plus, so 1.1 squared is 1.21, so 1.21x squared. So this here, we are going to use this, leave it for now. Let's now focus on our trapezium. So we said earlier that this length here is this length here. Okay, so if we draw this trapezium out, we have, this has 10 meters. This is x. We're trying to work out CF, so we leave that, and that's AD. Right, so we just worked out this, by the way. This is y, so let's label that y, okay, because that was y here as well. Quickly to recap, this y here is the same as that y there, okay, so that's why I've labeled it y. And I know what y is, so that can go in here when I need it, not now. Now, we are trying to work out CF, all right? So if I draw a dotted line from there to there, and also the same here, and I mark this point X, CF is going to be all of that 10, take away this and take away that, right? So if I find one, and remember they're symmetrical, right? So if I find a to x, an expression for a to x, I can multiply it by 2 and then take it away from the 10, all right? And that will give me CF, right? So this triangle is a right angle triangle. Let's use that to do that, okay? So remember this is x, so that's going to be x as well. So right here, I'm going to write down an x, and this is now a right angle triangle. So I'm going to be working with that tiny triangle right there. So that's a to x, and this is just x, and this is of course y. Okay, so how do I find an expression for a to x? I can use Pythagoras Theorem once again. So this is c, the hypotenuse, and let's call this a, and let's call this b. So therefore it's going to be a squared plus b squared is equal to c squared. And what's my a? My a is a to x squared, plus my b is x squared is equal to y squared. So now let's substitute our y value in. Now it's in the form y squared. So rather than put all of this in and then, making it messy, why don't we just make y squared right there? So to square y again, what we can do is just square both sides. So we can square this, and that would get rid of that square root. So y squared is going to be 4 plus 1.21 x squared. So now we're going to substitute that value for our y, right there, our y squared. So therefore, ax squared, remember it's ax squared, and please don't square these individually. Ax is referring to this length here. So plus x squared is equal to 4 plus 1.21 x squared. Remember, we are not squaring this, okay, because it's already as y squared. All of that is representing y squared, okay? And now we just need to make ax squared on its own. So ax squared is equal to 4 plus 1.21 x squared, and we'll take the x squared on the left-hand side to the right-hand side by doing take away x squared. And then we can just, these are like terms, right? So we can take them away. So it's going to be 1.21 take away 1. So 1.21 take away 1 leaves us with 4 plus 0.21 x squared. This is ax squared. Now, to find what just ax is, we square root that other side. So 4 plus 0.21 x squared. Now, to remind you, what we were doing is we're finding this. That's the same as that right here. And we're going to take that away from 1. So 2 lots of ax is what we need now. Okay, so we need 2 lots of ax. So therefore, CF would be equal to 10 minus 2 lots of ax. Okay, remember, 2 lots of ax are these two right there. Okay, and they're the same. So CF is going to be equal to 10 minus 2 lots of ax. So CF is going to equal 10 minus 2 bracket, there's ax, so square root of 4 plus 0.21 x squared. And then we can do without the brackets now, so it's 10 minus 2 root 4 plus 0.21 x squared, and that is your final answer. That's what it wants you to show CF is equal to, right here. So as you can see, we've got 4 plus 0.21 x squared, which is the same as 0.21 x squared plus 4, okay? That part is all good. And that's it. We've come to the end of this lesson. I hope you've enjoyed this video. Please don't forget to give it a thumbs up. And if you haven't watched paper 2 predicted paper, then you can find it on the channel. I wish you guys all the best for your exams. I'll be praying for you. I'll be rooting for you guys. And come summer, I want to see you guys beaming with smiles as you pick up your results. Bye for now, guys. See you in the next one.